there was a time, which you probably do not remember, where you actually work, you go to the office, you have the telephone, and you leave the office and you're off. And now, I get calls, I got the call last year when I was attending a conference in China from Israel for a project from a guy who was actually in US. He said, come on, can we do it later? And this is the same with life. People tend, in fact, I think I tend to go much faster than I should. And I think, yes, I like to finish up, to wrap up this, but I don't want to take more than this time and leave that time. So, I just wanted to say, so let's say, one quick thing that I want to use to finish up this is okay. What's left with data flow analysis? Okay, many things actually. The whole book of data flow analysis. Okay, there are several elements which are left. One is, well, of course, algorithms. I can spend weeks talking to you about different algorithms, and I gave you only flavor. I actually hope you understood what the problem is or what the algorithms are. I can look at complex structures. The things that we didn't think. We always work on integers. Let's have x and y. What if x is a pointer? What if x is a complex structure? What if x is an array? And that's again yet another big difficulty, and people can do that. Let me actually give you a very quick flavor of what is actually the complex structure. Okay, so basically you can do different things. You can actually, generally it's not just arrays and pointers, more alias. The real clinical thing is alias analysis. Because the real problem is not whether it's an array, whether it's a pointer, whether it's a different kind of alias. The problem is whenever A, I, and AK are the same element or not, whether the two elements point to the same element, correspond to the same element or not, whether whatever it is. And basically, you want to do things like, okay, of course, you want to do some alias analysis, and that there is a huge discipline which actually took a big momentum now. And it is a very nice, they can actually identify statically a lot of aliases. But again, being a complex problem, they can actually identify a superset or a subset of aliases, and with approximation that depends on the time. But then what you want to do basically, you want to be either conservative or at least. So conservative means let's consider everything that I can distinguish as unique. So in this case, you say whenever you have AI and AK, if I don't have any clue which tells me how to distinguish I from AK, I would say they may be the same. And so one thing I can do is I can basically say I can actually consider them the same element if I cannot distinguish them, and this gives you a conservative result. Obviously it gives you much more than you need, but it gives you something. Or you can get actually something which says, oh, let's consider them distinct unless they are really the same, and then it's actually a sort of more thorough analysis, and you actually get more cases. And when to use what? It really depends on the goal of analysis. So you go for that. One other thing which is important is the scope of analysis, which can be intra-procedural or inter-procedural. Intra-procedural means within a single method or procedure. Inter-procedural within across method or procedures. Now, again, and I like to point that because it's the same problem of alias in a much simpler way to understand. You again have a trade-off between cost. In the former case, is a trade-off between decidability and cost. Here is a trade-off between time and cost. Okay, which is you can have two different things: context-sensitive or flow sensitivity analysis. What does it mean? It means that if I call the same procedure twice from foo and from bar. Okay. Context sensitive means this call and this return are paired. So I distinguish different calls. Context insensitive means that this call and that call are not distinguished anymore, so the return are not distinguished. Okay. So in order to pair, so the flow is I go through this, and continue here. To be able to do that, I need to understand that this call is different from this one. And so I need to save the return point. So I need to understand what the context of the call is. If once I'm here, I do not distinguish the context of the call, I can't tell you whether I can go back here or here. So I get sort of less precise analysis. How expensive do you think is to do context-sensitive analysis? Because the point is very simple. You have this schema, and you have, it's obviously the case it is much better to distinguish than not to distinguish, and they say it's a trade-off between cost and benefit.
So the net, you can call it from V and see from V. Exactly.
Okay. So the cost is, we used to have a nice slide, which well, never mind. If you have, go back to the slide. I guess I lost the trace on the slides. I have a call to either A or B, and then I have another call, and then blah blah blah. So if I have every time, let's say, if function A can call to A or B, and then each one can call to actually it is even right. So these are the number of calls you can actually do. Anytime, at this point, you can reach this point through this path, or this path, or this path. So basically, anytime, if from main call you call 10 procedures, and from each of the 10 you call other 10 procedures, and for each of the 10 you call other 10 procedures, after 3 steps you have 1,000 possible combinations. So the amount of combinations that you get in context-sensitive analysis is exponential in the worst case in the number of calls, which is actually really a big trade-off in terms of cost and benefits. So again, it's another case where it may or may not do this kind of execution. And now, very last thing today, because I want to steal the time from Natasha, is we actually mentioned, I don't want to say I yes see, but I mentioned you I mentioned you one classes of use of data flow analysis, which is analysis. I compute data flow information, and from that data flow information I can get a lot of information on the code. Variables which are used and not defined, methods that are defined and never used again, files that are open and not closed, procedures that are called and never returned, agents that are created and never terminated. Because by the way, we always mention definitions and uses of variables because they're the classic. But you can think about millions of things which has to be paired by actions and other actions. Opening and closing the file, opening and writing on the file, creating and terminating an agent. You have millions of things that actually may be treated with different classes of operation that may be paired in good things. Also, locking and unlocking of code. So you, for example, may use data flow analysis to compute a superset of the lock-unlock set of pairs and see whether there is some dangerous thing. Again, you don't get a final answer saying you definitely have an error, but you get the warning saying, these two seems not to pair together very well. Okay, and so you have a lot of information from analysis. Another kind of information is from testing. Okay, I'll tell you 2 cases. One which is the classic, which is basically, and we mentioned at the beginning, you want to do structured coverage and you want to cover more than just single statements, single branches, single conditions, and there is a huge amount of literature of that. You want to cover paths, and paths are too many. So you want to actually use DU pairs as a core element to cover. So you have things like all DU pairs means exercise each DU pair at least one by one test case. So which means you don't really stop when you actually tested this statement. But if this statement uses x, y, z, k, you want to actually, and x, y, z, k are defined in several places above, you want to actually be sure that you tested every possible combination for at least one path. And of course, if this means walking through complex paths, you actually get a better approximation of what is important. And then you actually want to do all the U paths, and then we go to the distinction between pair and path. If this is defined here and used here, and there are several different paths, you may have to try every possible path. Or you may want to do only all definitions, which is you want to at least test one user after the definition. And basically there are at least a dozen of different criteria, even more, that you can use, and could actually give you a lot of information about the executions. Interesting, nice, not used in industry, for two reasons, actually, one reason probably. Well, some of you do have a job or have experience in industrial experience. Did you use any coverage tool? Yes. So, many industries now use coverage tools, correct? You were saying something? You have experience with it. Yeah. Okay. So if you go to industry, not everybody uses coverage tools, but I would say that in average you need a reasonable industry. So of course, it depends on which kind of industry. But let's say an industry with a reasonable process. In most cases, they would actually use usually statement coverage, sometimes branch coverage. Anything else that actually you compute in terms of coverage? Usually statement branch. Sometimes, well, if you go to aerospace, it's actually in CDC, of course, but in general, it's statement of branch. You know when they started using these tools? Less than 10 years ago. If you go back, like mid-90s, very few companies were using tools. At the beginning of 90s, very rarely. Before 90s, nobody. You know when this technology was actually developed and started probably early 80s? Even before that. Yeah, 70s. So it took almost 20 years to become common practice. And this is actually for two reasons. One is difficulty in building these tools. All things, if you think like statement coverage, how much time it takes to understand what statement coverage is? You can cut it in seconds, probably. It's really trivial. Actually, the studies, there are full papers with long discussions, so there is a bit more than behind that. But the basic concept is very simple. How much time does it take to build a tool for computing statement coverage? Now, it's much easier now with Java, because the Java virtual machine gives you a very nice framework to build the tool and to monitor events. But I remember in the late 80s trying to use open source tools for practicing, well actually also early 90s, for practicing statement coverage in classes. I had this fantastic experience of this tool which was running underneath a program, and the program was computing different values depending whether it was instrumented or not. So the tool was actually changing the behavior of the program. And the reason is actually that it's really difficult to build this tool, especially at the time of C or C++, where you had to interact with the actual virtual machine, which is more complex than for Java. So there is one difficulty, which is building the tool, and the tool, if building the tool is expensive, you need a market to build a professional tool. And the other thing is get the benefit out of it. Now, industries use these numbers to monitor the overall progress, and I don't think they feel like these are very useful step forward. They may actually feel they will be useful in 10 years. Who knows? Or maybe never. Okay. The other thing, and this is actually yet another open research problem, is how effective these measures are compared to coverage. And I don't think there is a final answer yet. So, I would say, if you cover all the U pairs instead of all branches, I'm not sure how better you do actually. I think you do better, but people did not yet measure exactly how better you can do, even in empirical terms. And so it's really difficult to make the case. Okay? Very last point. tell you an application that is new of technical analysis and that we did as actually we presented this as at the international conference a few years ago. So it's a very new thing, which I think is very nice. Okay, and I like it because it gives you a sort of flavors. And I don't have slides here because I was not thinking of telling it to you. So, testing object-oriented software. So you have object-oriented software. You know, there are several different problems in testing object-oriented software. One of the first problems you have is actually state. Okay, so you have an object. You have several variables, state variables, and the behavior of the object depends on the input, the state, and gives you the output, and changes the state. Right? So now, I can use all the criteria that I taught you and the ones that I didn't taught you. So there are millions of criteria, functional, structural, fault-based, and they can drive a huge set of inputs. And most of the testing so far has been focusing on input-output, not state. Okay? So if I go to the state and use different criteria. Now, in the functional testing, if you go to functional testing, which is something that we didn't have time to talk to, functional testing, do you know how to model state-based behavior? Any idea of how to model state-based behavior in general? The answer is easy. It's not that difficult. Final state machines, for example. So a final state machine is a very nice way to model behavior. Actually, there is one other which is state chart, which is the same thing. Actually, don't tell it to my friend David because he will get upset because he got so much knowledge about state charts, and they're nice actually, but you know they are basically hierarchical final state machines. You know, even if he thinks it's the best invention of the world. But okay, so yes, we do have functional specification which are state-based. So in fact, if you go to model-based testing and you use state-based machines, you can actually get interesting. If you can model the state, you can get interesting functional test cases. And then you buy, you go and you can buy fantastic tools for dealing structural testing. And so you have structural testing. And you get statement coverage, branch coverage, condition coverage, path coverage, procedure code coverage, and that is for, and they say this is for object-oriented software. The truth is that statement of branch coverage makes some sense in procedural programming, because then there is this idea that the function or the computation goes through statements. So covering statements makes sense. It does make much less sense for objects, because it's not just a matter of sequential computation, it's more like a matter of state-based computation. Okay, now how do you measure coverage on an object with state? The answer is obvious because but it's not that obvious to see what the relation is. Let me tell you quickly because I don't want to take too much time to okay. I have a state variable, okay, let's call it x, just to be creative, okay. And I have a method, let's call it m1, okay, that changes the value of the state variable. And then I have another method m2 that also changes the state of the state variable x. And then I have another method m3 that uses the state of whose computation depends on the state, which means it uses the value of x. And you notice that I use define and use. And then I have another method m4 whose computation depends on x, which means it uses x. Now, what we did, and I was actually fairly successful, was, and what you can do is you can actually compute the definitions and uses only on state variables for objects. And then you want to actually walk through and see pair M1 and then call M4 and then call M2 and then call again M4 and then call M1 and then call M3 and then call M2 and call M3. Because then you exercise much better the state. So you can actually compute the coverage of objects by pairing methods according to the data flow information on the state variables. And that's a very nice application. And then we started years of research, because then you want to actually do integration testing, so inter-class testing, where you have to actually pair method M and method N, which comes from a class called an object A and an object B, which are not directly related. And what happens there is that if you are a good or a decent Java programmer, you would use set and get. So if you compute definitions and uses, plain definitions and uses, you would actually get the information that you must actually call a set and a get, and so on. So, and we had a very nice presentation last year at ICSI about how to compute, actually this year at FACE, that one was, how to compute the contextual definition and use information, which means you want to know that this X has been defined by this method that calls this method that calls this method that actually defines this one, and it's used by this method that actually calls this method that calls this method that uses this one. And so you want to pair these two instead of these two. Okay? And I don't explain you why, because it's late, but if you're interested, you can actually get it in a physical time. Yeah. Okay. That's the end of my class. I hope you actually got some information about this course. Well, my goal today in these 2 days was not to tell you everything about software testing and analysis, but rather to tell you that there is a lot of things to learn about testing and analysis. It's more like that if you think that this is actually, you know, if you've got the message that it's important, and it is important, and it's complicated and it's interesting, it's worthwhile actually spending some time studying these technologies. Also, it's one of the most fastest growing research field. So if you are, depending on where you are, master's in PhD, you think of going to the PhD, you're at a PhD program, this is actually a kind of technology or a kind of field where you really see a lot of growing interest. In the last 10 years, the number of publications and conferences in the field has been growing by an order of magnitude. I mean, 10 years, do you know a international conference on software engineering? Some of you should know. I mean, it's a major event in software engineering, so one of the major events. If you take the proceedings of the International Conference on Software Engineering 10-15 years ago, there were 1-2 papers on software testing. Now, the majority of the paper, the topic with the majority of the paper in the is actually software testing. And this gives you like the way, because my personal opinion is that software engineering is moving and has moved already from from the early stages where building software was important to the mature stages where building software is possible, and we need to build high quality software. And so testing is becoming really the next challenge of software. Okay, now I guess Natasha wanted to tell you something about how we organize the exams for tomorrow, and I'm just sort of blowing here, so that's hopefully she will be back soon. I'm not sure how much you are aware of how we organize the thinking of the trend. Now Natasha will finish your lectures on model checking, and then tomorrow morning there will be exams. The question is first, how many of you are planning to come tomorrow for the exams? Okay. Now, great. Now, out of the ones who plan to come, I guess there are two groups. The one who are either in their PhD program or entering the PhD program in the next 6 months, and the one who are either in the early master program or entering the master program in the next 6 months. So, who are the first group, PhD or candidate? Okay. And who are the second group, master or master candidates? Okay. We will actually, the exam will be structured as follows. There will be a set of questions from There will be a set of questions that comes from Fernando and Antonio, and it will be concerning the former part of the last week of teaching. And the reason for having written questions is that basically they are not here, so they can talk to you. So we will give you some written questions, and we expect you to answer the question. We bring the answers back to Lugano, and they will actually play them. Okay. So the second part of the exam will be on top of what we learned yesterday and today. It will be a colloquium or an individual discussion with me and Natasha. So we will actually ask you, and it will be the same exam for both master and PhD candidates, but we'll use a different grading metrics and different, because there is a different kind of also of exams, because I guess you understand that I think there are at least 2 scholarships that you wants to come to Lugano for masters, and of course we want to have a list of a sorted list of people to see who is maybe interested after that. And while for PhD program, each PhD student in Lugano is supported either by the faculty or by a project. So in the case of masters, it's more like a competition for, unfortunately, only 2 scholarships. For the case of PhD, it's more like a tuning of expertise. So if someone wants to come for a PhD in Lugano, you will be asked to apply as everybody else, and we will actually interview. It's a sort of pre-interview, something like that. Okay, so it's not just, it's not exactly a competition, but more a positioning in a scale. Okay, so we will probably discuss different issues, also because we expect different background. In terms of my lecture, I don't know whether Sasha sent you the message that I sent him yesterday. He did not. Okay, hopefully he will survive and come back to you. So I sent him a message about I gave him the website of my book. I don't know how many of you have reached the website of the book. Okay, the website of the book has slides for most of the lectures. So last year I used some of the slides for chapter 1 and 2, some of the slides for chapter 19, which are not on the website of the book. And today I used, I didn't use slides, but what I discussed is actually in the chapter 6. This is in partially chapter 12, which is that of testing. Okay, so you can basically have a look at the full set of slides to understand what is said and maybe walk through a bit. Chapter 1 and 2, which are short and introductory chapters, are on the web from the book. I sent to Sasha the PDF for chapter 19, which is analysis, and I will send the one for data flow. I do not expect you to be actually proficient in all the topics, because it's a lot of material, it's a lot of difficulty, and you don't have that much time. But I do expect you to be able to reason to discuss it, right? But Natasha will have it. So I break again, and then we start to discuss. Unless you have questions.